When you look up at the night sky, it looks, well, incredibly static, right? Just these peaceful, unchanging points of light. But actually, the reality is completely the opposite. Right now, as we speak, our solar system is an absolute highway, just teeming with robotic explorers racing around at millions of miles an hour to unlock the deepest mysteries of our universe. Welcome to today's Explainer. We're going to decode the solar system by basically riding shotgun with the most advanced spacecraft ever built. Okay, let's dive into this. Think about this for a second. What if you could literally hold the exact origins of the solar system, and maybe even the origins of life itself, right in the palm of your hand? I mean, thanks to a whole new wave of daring space missions, we aren't just staring at the primordial past through telescopes anymore. We are physically bringing it right to our doorstep. We're shifting from just observing the ancient cosmos to physically interacting with it. So, here's our flight itinerary for today's Explainer. We are taking a cosmic road trip. We're going to start with the primordial past, then take a journey to the core. Next, we'll plunge into the ocean worlds, and finally wrap things up with a cosmic coincidence.
All right, Section 1, the primordial past. Let's look at the secrets of asteroid Bennu.
To unlock these secrets, NASA's OSIRIS-REx spacecraft pulled off what was essentially a daring cosmic heist. It tagged a near-Earth asteroid and brought a piece of it back home. The total haul? 121.6 grams. Now, sure, that might just be the weight of an average apple, but this is the largest extraterrestrial sample ever delivered to Earth. And because it was carefully curated under a strict nitrogen atmosphere to prevent any earthly contamination, this absolutely pristine material is actively rewriting our science textbooks. When researchers finally opened up this time capsule, they found an absolute treasure trove. We're talking abundant carbon, water, sugars, and, this is crazy, all 5 bases required to build DNA and RNA. Plus, they found a complete set of evaporate salts. And that's a massive deal. It tells us that deep inside Bennu's ancient parent rock, there were these insulated underground pockets of warm alkaline saltwater. It was basically a mineral-rich hydrothermal broth just sloshing around out there in space. So why does this matter to us? Well, it tells us that the exact building blocks for biology were actually synthesized and processed inside these parent asteroidal bodies long before the Earth even existed. This essentially proves the theory that asteroids like Bennu likely brought the exact ingredients for life directly to early Earth during ancient impacts. You are quite literally looking at the recipe for life cooked up in the vacuum of space sitting in a laboratory today. Let's move to and see how this builds. Section 2, Journey to the Core, the meta world of Psyche. So we've looked at life's building blocks, but what about the building blocks of the planets themselves? Now, most asteroids you hear about are basically just giant lumps of rock, dust, and ice. But asteroid 16 Psyche is radically different. It's thought to be an exposed, metal-rich planetary core. Think about it. We can never drill down to Earth's core. The heat and pressure beneath our feet are just way too extreme. So flying a spacecraft all the way out to this metal world is quite literally our only way to directly examine the heart of a rocky planet. To get to this metallic time capsule, the Psyche spacecraft has a pretty epic journey mapped out. It launched back in October 2023, and it's heading deep into the main asteroid belt between Mars and Jupiter. And it actually just completed a crucial milestone, a Mars gravity assist. By slingshotting around the red planet, the spacecraft caught a 1,000-mile-per-hour boost and shifted its orbital plane by about 1 degree relative to the Sun. That puts it perfectly on course for an August 2029 arrival. Once it actually gets there, how do you even study a metal world? Well, Psyche is going to use these unique solar-powered Hall effect thrusters to perform this highly choreographed orbital dance. It spirals down through different observation zones. Orbit A maps the magnetic field, then it descends to Orbit B for topography, and finally it drops down to a remarkably low 47 miles above the surface, where it'll use specialized spectrometers to map the asteroid's exact chemical makeup. All right, moving further out. Section 3, the ocean worlds, piercing the ice of Jupiter's moons. We are shifting our focus even further out now, deep into the realm of the gas giants. Right now, 2 massive flagship missions are simultaneously hurtling through space to hunt for subsurface oceans. We've got NASA's Europa Clipper and the European Space Agency's JUICE mission, and they have distinct but really highly complementary targets. Clipper is focusing on intricate flybys of Europa, while JUICE takes a broader tour of the Jovian moons. This isn't a space race or a competition. It's a coordinated international fleet pushing into the deepest frontiers of the solar system. Now, what's really interesting about this slide is the sheer contrast in scale. Jupiter's moons are massive, planetary-scale bodies, right? Yet the SUDA instrument on Europa Clipper is searching for something incredibly tiny. This surface dust analyzer is so microscopic in its sensitivity that it can detect traces of organic compounds in ice grains ejected into space. It can literally detect signatures of life, even if the sample contains less than a single bacterial cell. It's the absolute ultimate needle in a haystack detector, searching the void. But these probes aren't just looking at the surface dust. They are looking through miles of solid ice. Both spacecraft carry these powerful, dual-frequency, ice-penetrating radars. These instruments are going to blast radar waves up to 30 kilometers deep into the ice crust. That's going to allow us to finally see the hidden structures, map the ice shell thickness, and definitively locate those vast liquid water oceans that we are pretty sure are hiding right beneath. Which brings us to Section 4, a cosmic coincidence, catching an interstellar visitor. As if exploring origins, metal cores, and alien oceans wasn't enough, these robotic explorers actually crossed paths with a rare visitor from another star system. Set the scene here. It's November 2025. An interstellar comet known as 3I/Atlas, meaning it originated completely outside our solar system, passes directly between Europa Clipper and JUICE. This was an incredibly rare alignment, and the mission teams quickly realized they had a true once-in-a-lifetime opportunity on their hands. I absolutely love this quote from Dr. Philippa Molinex, a planetary researcher involved in the observation. She said, "This was the first time we've had simultaneous direct views of a comet's coma from two directions. This wasn't planned years in advance. It was pure bonus science." The teams informally coordinated their operations on the fly, pointing the ultraviolet spectrographs on both spacecraft at the same target at the exact same time. And this brilliantly illustrates exactly why having a multi-probe fleet is so incredibly powerful. Because they had vastly different vantage points, Europa Clipper gave us a view of the comet's dusty night side, while JUICE imaged the glowing gas on the day side, literally watching elements break apart in the intense sunlight. Together, they essentially built a comprehensive 3D picture of an interstellar object on the fly. But the observation party didn't even stop there. The Psyche spacecraft, cruising some 33 million miles away, also turned its cameras to watch the comet over an 8-hour period. And back near Earth, the Hubble Space Telescope mapped the comet's teardrop shape and dust dynamics, while the James Webb Space Telescope conducted deep chemical analysis. It turned into this unprecedented solar system-wide observation campaign of a single interstellar rock, utilizing literally every tool at our disposal. So we've got pristine asteroid pieces revealing the dawn of life on Earth, a metal core preparing to show us what's quite literally beneath our feet, and a fleet of probes piercing the ice of ocean worlds, all while casually studying interstellar interlopers together. So it makes you wonder, when these explorers reach their final destinations by 2030, what profound truths are they going to reveal about our place in the universe? The textbook isn't just being rewritten right now, it is being entirely reimagined. Keep your eyes on the stars, folks, because this cosmic road trip is just getting started.